Okay, in this video we're going to be doing geometric sequences. So in this time, instead of doing adding and subtracting to get from one term to the next, we're actually going to be multiplying. Okay, so they're going to have a common ratio, so multiplication or division to get from one term to the next, and we're going to use r's because it's a ratio, division, a multiplication of a fraction. So we have our recursive and explicit. So just remember, recursive has to have the a sub n minus 1. We could have an n minus 1, but if it's attached to that a, that's going to represent a recursive because a sub n minus 1 means, hey, what's happening to that term before it? And then we're going to increase that rate each time. Okay, so first we got to decide if it's a geometric sequence, so are they increasing by the same thing? What is a sub 1 and what is that rate? Okay, so some of these fractions might not be as easy as you can tell. So what I do, I put this over this over this. So I'm going to have 6 over 3. It should be equal to 12 over 6. It should be equal to 24 over 12. It should be equal to 48 over 24. If I divide all of them, that constant rate this time is going to be 2. Sometimes it's going to be a fraction like 2/3, and it's not going to be something easy to see. So technically we can see 3 times 2 gets me to 6. 6 times 2 gets me to 12. So that's pretty easy, but if it's an ugly fraction, you have to set it up like this to be able to find it. So then my a sub 1 this time is going to be 3 because that's my first term. Okay, so this one I do 6 over 3. Should be equal to 9 over 6, which is equal to 12 over 9, which is equal to 15 over 12. 6 over 3 is 12. 9 over 6 is 3 over 2, which is not the same thing, so it is not a geometric sequence. This is actually an arithmetic one because we would be adding 3 each time, so that constant distance there would be 3, but it is not geometric because we can't have a common ratio to get from one to the next. Okay, what are the indicated terms of the geometric sequence? Find the 10th term of the geometric sequence. Okay, so I don't know what 9 is, so I need to use my explicit equation. So if I go back, oops, there's my explicit equation right here. That's what we're going to be using because I don't know what's occurring before it. So I know my a sub 10 is what I'm trying to find. My a sub 1 is equal to 4. Let's figure out that rate. So I do 12 over 4, which should be equal to 36 over 12. So my rate then is going to be 3 here. So when I plug it in, I'm trying to find a sub 10. It's a sub 1 times my rate. Here's the key. You have to have your rate in parentheses because if your rate is negative, it needs to be sitting in a set of parentheses. Okay, and then it's to the n minus 1 power. My n always represents this, so that nth term we're plugging in. So 10 minus 1. We're going to go ahead and simplify. 10 minus 1 gets me 9, and then I'm just going to type this in my calculator. So I'm going to type in 4 times parenthesis 3 and my parenthesis to the 9th. So that 10th term would be 78,732 because we are multiplying by 3 each time. So it's going to get very, very large very, very quickly. Okay, my next one, we're trying to find a sub 9. So a sub 1 is 1, and my rate this time, so I put negative 3 over 1, it should be equal to 9 over negative 3. So my rate is negative 3. So I'm trying to find a sub n. I don't know what the 8th term is, so I'm going to use my explicit formula. My a sub 1 is 1. My rate in parentheses is negative 3. My n always represents the nth term I'm trying to find, so 9 minus 1. So if I simplify that, 9 minus 1 is 8. So I'm going to type in 1 times negative 3 in parentheses to the 8th power. If you don't use parentheses, you'll get a negative answer, and my answer is not negative. So it is 6,561. Okay, now we're finding the second and third terms. So I know my a sub 1 is 2. I don't know what rate this is increasing by, so that's what we're going to have to solve. I know my a sub 4 is negative 54, and I don't know what it's occurring before it, so I need to use the explicit formula. So that's the a sub n equals a sub 1 times the rate n minus 1. I can't use my a sub 1 starting off here because then I'd have 2 a sub 1s. So I'm actually going to start it off with that a sub 14 since I know it. And then we're going to have that a sub 1 times I don't know my rate. My n now is 4 because that's what I know. I can plop in my a sub 1, which is 2, and I can plop in my a sub 4, which is negative 54. That's what we found. That's my 4th term. So I'm going to get negative 54 equals my a sub 1, which is 2. I don't know my rate. 4 minus 1, which we already had here, was 3. So we're just popping in information that we knew. We knew a sub 4, we knew a sub 1, and I knew my n was going to be that 4. So we're going to divide by 2. The opposite of cubing is cube rooting, so you need to cube root this to get your rate to be -3. Problem is I'm still trying to just find these two terms. So to get from one term to the next, we multiply in these situations. So 2 times -3 is -6. That times -3 is 18. Okay, arithmetic, we're adding and subtracting. Geometric, we're multiplying. Okay, what's the second term? So a sub 1 equals 3, a sub 3 equals 12. I don't know my rate, so that's what we're going to have to find. So I'm going to plop them in. I don't know what's occurring before 12, so we're using explicit again. So I know it's a sub 3 equals my a sub 1 is 3. I don't know my rate. Here's my n. And then I know that a sub 3, so we're going to plop them in there. 3 minus 1 gets me 2. So we're going to divide by 3 to get 4. Opposite of squaring is square rooting, so my rate this time is 2. So I'm multiplying each of these by 2 this time. So I'm multiplying 3 by 2 to get 6. So you're just popping in your known information into your equation and being able to solve for r. You need to get rid of your terms and get them to be what they're supposed to actually equal. Using a geometric sequence. So when a ball bounces, the height of its consecutive bounces from a geometric sequence. What are the heights of the 4th and 5th? So I'm trying to find a sub 4 and a sub 5. So first bounce, so a sub 1 is 100. My third bounce, so a sub 3 is 49. I don't know my rate, and I don't know what occurs for number 2. So I'm using my explicit formula again. So my a sub 3 is 49. I plop in my a sub 1. I don't know my rate. And then this was what was sitting here, so my n is going to be 3. So I'm going to solve, so let's go ahead and divide by 100. 3 minus 1 for that exponent is now 2. Opposite of squaring is square rooting, so my rate is 7/10. Okay, so I know my first one was 100. I know my third one is 49. To get from my third to my fourth, I need to multiply that little guy by 7/10 because that was my new rate. So 49 times 7/10. This is going to be 34.3, so there's one of them. And then to get my fifth one, I need to multiply by 7/10 again to keep it going because that constant rate. So 24.01. So those are the fourth and fifth bounces in centimeters. Okay, a shortcut to being able to find it if you're only missing one term, instead of adding them and dividing by 2, because we're multiplying, we need to multiply and then do an opposite of here, so taking the square root. So I could do 48 times 3 and take the square root of it. 48 times 3 gets me 144. Square root of 144 is 12. Or you could do the route where it's a sub 1 is 48, a sub 3 is 3. You plug it into your explicit equation because you don't know what's occurring before 3 or before 48, and solve it, and you'll get the exact same answer. This is just a shortcut in case you wanted to do it. But you can only be missing one term to do it.